Number 27. The dissolution of an ionic solute in a polar solvent can be imagined as occurring in 3 steps as shown in the figure. Okay, so what's happening? Step 1, separation between the ions in the solute is greatly increased, just as will occur when the solute dissolves in the polar solvent. Okay. Step 2, the polar solvent is expanded to make spaces that the ions will occupy. Okay, I guess these are some of these spaces that it's making so that the ions can kick in and fill the spots there, right? So it's kind of expanding it. In the last steps, ions are inserted into the spaces in the polar solvent. Which of the following best describes the enthalpy change? Easy stuff. When you are trying to separate someone, it's kind of like this, right? I don't know, like, let's say you're not doing your goddamn work. So I'm like, you need to break up with your boyfriend, or you need to break up with your girlfriend to, you know, like freaking focus on your schoolwork. And then obviously you're not going to listen to me because, oh my God, I love my girlfriend, or I love my boyfriend, or whatever, right? So yeah, it's going to take a lot of energy for me to break you two apart, aka the very idea of breaking off intermolecular forces or breaking off covalent bonds. Just in general, anything breaking in the world of chemistry, it is an endothermic process where the energy must be absorbed in order to use that energy to break off, I don't know, covalent bonds, intermolecular forces, whatever you want to call it. In this case, we're just trying to break off the intermolecular forces. Regardless, it's going to take energy for you to do it. So this part is endothermic. Then same reason, this is also going to be endothermic, because how do you make these spaces? You need to separate some of these molecules, and the fact that you're separating them means you're breaking off the intermolecular forces. So step 1 and step 2 better be endothermic, so you can get rid of A and you can get rid of C. So step 1 and 2 are endothermic. And lastly, this one, that's the formation. Think of it this way. If breaking off is endothermic, then formation better be the opposite, aka exothermic. So the answer choice D must be correct, where the 1 and 2, breaking off, is endothermic process, but formation of any new, intermolecular forces or bonds or whatever you want to call it, any new formation in the world of chemistry, well, that's an exothermic process.